Bismillah ar-Rahman ar-Rahim. Today we will discuss gas supplies. The first item is gas cylinders. Of course, most of the large ones are stored in the upright position apart from internox, which is stored horizontally to keep the two components of it in a gaseous state. They are stored indoors, of course, to avoid extreme cold, and they are stored separately because we have inflammable anesthetics as cyclopropane. Of course, it's not being used nowadays. The medical ones of cylinders are made of high carbon steel or manganese steel or aluminum alloy. They ought to withstand pressure more than its 65 to 70% of its working pressure. But if it falls on a concrete, it will increase its pressure and will have bad outcomes. Of course, they are identified by labels which are written on the cylinder. And then we have what we call the international standard of color, R32 by United Kingdom, which defines the colors of the different types of cylinders, as we know. Of course, auction black with a white shoulder, and nitrous oxide is blue. Of course, these colors are being changed in the United States. We have a plastic disc near to the shoulder. This plastic disc shows the year where the cylinder was last examined. Of course, they examined these cylinders by endoscopes, so that if there is a faulty one of them, they are being withdrawn. The interval is around from 5 to 10 years. On the top of the cylinder, we find a label summarizing safety precaution of this cylinder. Of course, the risk of explosion increases the presence of oil and with the and other flammable liquids, which are being used with such cylinders, which are supportive of combustion. Of course, as we said, they are made to withstand a pressure of 65 to 7% above the working pressure. Of course, whenever I use a cylinder, we momentarily open it to remove all the dirt or any dust present before it reaches the anesthetic machine. And then we must open it slowly to avoid the adiabatic heating of this gas, as we said before. And we must open it to a full term, because whenever the pressure is full, it may decrease the flow. This picture upwards shows that the cylinders are being stored indoors in a special area, away from the theater and the rooms where we use oxygen. And this is the meaning of shuttle. Shuttle means traveling back and forth, as we will see later on. Of course, whenever I use the valve, I ought to close it not tightly, otherwise the plastic component of the spindle will be affected. So the valve of the cylinder is made of a spindle, as we can see. Spindle is a part where it can be shifted upwards and downwards. Of course, it's made in a plastic, and as we said before, we must manage it in a good way, otherwise it'll be broken. Screwed upwards and downwards. Again, it's a plastic. And then we find around the spindle, we have a gland and a gland nut. These are capable to decrease the leak. As we can see, we have the pin index system where we have openings to fit these are the hole to fit the pins present on the yoke of the anesthetic machine. Apart from the pin index system, as we said before, we have what we call two another system. We have the large ball nose cylinder, which are of oxygen and of large air, helium, and nitrogen cylinders. These are right-handed internal threaded. You thread it in a right with your right hand. You see, apart from the other inflammable cylinders of hydrogen, other flammable gas, which are in another left-hand thread in a difference. And this is the ball nose, and this is the nitrous oxide cylinder, where we have an external thread, as you can see. And you can see from the upper part of the cylinder the wheel. We have wheels also to control the opening of the cylinder. Of course, this system cannot they protect partially against the incorrect connection. Pipe oxygen supply to avoid excessive change of cylinder. We have what we call the main fold. The main fold system is made of two banks of cylinders, as you can see from the figure, where each bank has three cylinders. As you can see, they are attached by loops, as we can see, and this loops is attached to a center compartment called central control box by the coiled tubes. Of course, this compartment has a reducing valve to reduce the pressure from 137 bar to 10 bars. And we have during this in the system in the central box what we call the pneumatic shuttle mechanism. Shuttle mechanism, it is a system to change shift from each bank whenever the pressure in one of the banks is being decreased. It is a mechanism magnetically working so to shift to the other bank. Of course, we have another system of cylinders present whenever this system fails. Of course, as we said before, the pressure is being decreased to 10 bar, and from 10 bar is going to be decreased to 4.1 bar to be transmitted to the stator through the pipe system. Interlock supply, as we can see from the figure, it is a preparation of two gases of oxygen and nitric oxide. Both gases are present in a gaseous state, so that they can be transmitted in a concentration 50-50. But if the temperature is being decreased beyond minus 5.5, below the gas, nitric oxide will be shifted to a liquid, and then by time, whenever this oxygen in the up of the liquid is being ended, some of the gas of the oxygen, of course, comes to replace, and at the end result, finally, we'll find that the cylinder will deliver an hypoxic or anoxic mixture of nitric oxide and less amount of oxygen. So we ought to have a system to keep the temperature not less than 10. And we have what we call the dip tube. This dip tube is made to remove all the liquid present in the cylinder. Compressed air supplies. It's made of a central compressor planet, compressor planet. It's the economic source for large hospitals. It's duplicated because in case of we have surfaces or repairing, so we don't have to wait till we finish this procedure. So they are always duplicated. There is air intake on the top. The air is being taken, of course, out of doors, away from the rain, snow, and dust. Otherwise, they will be affect the entrance of such air. And then we have a preliminary filter and a silencer. It makes less noise. This is as the point which we put it in front of the pistol, so that will not make noise during shooting. And then we have a compressor. This compressor, of course, induces cooling of the air. And then we pass this to a non-return valve to a large reservoir. This reservoir maintains a constant air pressure. It maintains a constant air pressure. And then we have filters. After that, it's being dried by suppose silica, and then we must put in our point that the compressor is always lubricated with oil, so we ought to remove this oil, otherwise the patient will develop what we call oil pneumonitis. And coarse droplets of oil are being baffled. I try to find from the dictionary the word baffled. The word baffled means that it is a confused situation. I don't know what's the correlated, but I think that is a way to remove the large particles from the components. As we said, it must be dry by silica. Of course, you must remove the humidity and keep the dew point less than minus 40 degrees Celsius. And we must remove, of course, bacteria. We have filters. The pressure sometimes reaches 6.9 bar, which is too much for working as a gas in anesthesia. So we only use it in operating tools, you know, the drills and such force. But regarding anesthesia, of course, we must lessen this amount of pressure. Apart from the compressed air supply, we have the centralized vacuum system, which this vacuum system also looks like that of the central compressor planet. It consists of a pump, a large reservoir as the previous one, and a filter. And of course, we have a bacterial filter to dry also. And the point is the reservoir, importance of the reservoir, it maintains a constant suction, and it lessens the duty of the pump. The pump is all the time working, so it's large enough to save some the duty of the pump. We have always two pumps to maintain the vacuum less than 0.667 bar or 500 millimeter mercury. And you know the atmospheric pressure is 670 millimeter mercury, so it's less than the atmospheric pressure to induce a suction. Of course, we have a silencer to decrease the sound, as we said before, and it looks like it's a cavity system used in the operative theater to remove the residual parts of the anesthesia. You see, so this is what we call the centralized vacuum system. The suction apparatus, as you can see, it's made of a diaphragm and a spring and floats, two floats. These floats guarantee that if the container is being filled, it will not affect the system. It closes the system. So this is the way the two floats work. And of course, there is a knob to control the pressure upwards by the spring. Of course, this working pressure is around, as we said, 0.67 bar. So we must put in our mind whenever we use it in human cavities, it may induce a severe suction pressure, which is harm to the patient. The oxygen concentrator, of course, sometimes in remote areas where there is not available oxygen, we use what we call oxygen concentrator. It has a similarity to the central compressor planet, compressed air, as we said before, but in addition incorporates zeolite. Zeolite is a silicate compound. It acts as an ion exchange properties, molecular sieve, separating oxygen from nitrogen in air, similar to materials used to pack the part in the chromatographic columns. It's made of it's made of a system where compressed air is filtered. Then, of course, this air is being filtered and compressed and cooled and dried by silica gel. And then after that, it goes to the zeolite, which absorbs nitrogen. And we have what we call a solenoid valve. This solenoid valve directs the flow of the gas to one cylinder, absorbs nitrogen and water vapor, while absorbed gas from the other is drawn off by a vacuum pump. So this zeolite and this system of solenoid valve shifts the pure oxygen to the patient and removes the rest of it by pump outside. This system is being reversed. The valve is reversed every half a minute. It assures that the patient reaches having oxygen of around 90 to 95% with a rate of 5 liters per minute. Of course, the problem of it is the running costs for electricity and servicing. I'm sorry. But it's cheaper, of course, than liquid oxygen. We have around from 2 to 5% argon are present, and minimal amount of nitrogen are present also. Of course, the drawbacks of it creates a pressure not more than 70 kilopascal, which is not enough to work ventilators. But in bigger hospitals where there is a bigger oxygen concentrator, the pressure can be increased to work ventilators. Of course, we have what we call the terminal units, where oxygen nitrous oxide are coming out to be attached to a probe and a collar. It's quite obvious from the figure, if you increase the figure, that the collar of the nitrous oxide is larger than that of the oxygen. And of course, they are labeled with the coloring or to denote that whether it's oxygen or nitrous oxide. But of course, there may be some mistakes by attaching or interchangeable by personnel and through this system. So we have what we call leaks and faulty connection. Of course, as we said before, in the pin index system, where there is holes in the cylinder and there is pins on the yoke of the machine to fit. But sometimes there is leak, apart from the leak occurring the anesthetic circuit. But the pin index system has leaking points where the cylinder is fitted to its reducing valve. This is one of the points where leak can occur. The second thing, as we called, damage to the Bodok seal washer. This is a part as a seal, like the oil seal or such thing. This is present to minimize the seal in the cylinder, so it may be damaged. So this is what we call the Bodok seal washer, which is affected or wrongly connect. This will create a leak. Of course, this is a screw collar, as we can see, connection between the system of the circuits to ensure a proper lock. The point of, as we said, there is a wrong connection between nitrous oxide and oxygen by the non-trained personnel. So whenever of course, if I inspire 100% oxygen in case of instead of nitrous oxide, of course I'm going to be awake. But if I inspired 100% nitrous oxide instead oxygen while I'm under anesthesia, it will cause an abrupt decrease in the alveolar oxygen tension, and by the oxygen tension also. This is abrupt decrease in oxygen tension within a couple of seconds. It's more than that present in a patient with supposed chronic obstructive airway disease, because in such patients you have a reserve of oxygen. But in case of such a circumstance where I'm making the patient inhaling only nitrous oxide, it will cause abrupt decrease in the alveolar oxygen tension. Of course, there are many protective methods nowadays, the cut-off system in case there is oxygen failure. Of course, repair of the pipe system, as we know, the pipe system, of course, we have 4 points. We ought to know what we call the leak test. Of course, we pressurize this tubing system for 24 hours, and to assure that there is no leak. And if there is a confusing, this pressurizing is made in all the tubes with oxygen, nitrates, whatever. But if there is a confusion about the leak, we can use each pipe separately at a time. Of course, the particles must be purged or purging, remove all these particles present. This occurs whenever I open the pipe for 5 minutes, but this, of course, will cause drop of pressure. So this will induce an alarm. So the personnel must be identified. This is made. Of course, as we can see, gas from the selected output through a filter at a rate of not less than 150 liters per minute for 6 seconds to check for filters for particles. You see, these filters are made to collect these particles. Of course, each pipe system must be analyzed for purity. In case of oxygen, we must be assured that there is 0% of nitric oxide and 20% of air and 50% of antinox and 100% of oxygen. All this are examined from of course, the pipe system concerning oxygen. Sometimes at the joining points between the tubes, whenever we are repairing, we use carbon dioxide at that point to decrease the oxidation. This carbon dioxide ought to be purged whenever I end the procedure. So we ought to have not more than 300 parts per million regarding carbon dioxide in this system. Of course, water and oil, carbon monoxide, and carbon dioxide ought to be removed. As we said, this Bodok seal washer is a specialized washer present between the cylinder yoke. It is a seal between the yoke and the cylinder, the yoke of the anesthetic machine. So sometimes this is a source of leak. I hope that I accomplished my mission. I hope to see you. It is not a rough subject, but you ought to memorize the important notes about it. I hope I see you later, inshallah. Wassalamu alaikum wa rahmatullah wa barakatuh.